Okay. I'll start by. Hi, my name is Alex. As I introduced, I'm an exchange associate professor, and we'll start by introducing you to the Excel sheets that I've provided. So there are some color-coded terms here. The blue stuff you see, the blue sheets you see, are the sheets that must be filled in. Red sheets are the sheets, the same sheets with the name, are the answers. So they are the sheets already filled in. We are going to go through all those sheets and see how we are going to learn statistics. Okay, first of all, we are going to start with two terms. The first term is, let's we are going to start with we are going to start with two terms. First of all, it's population, and the second is sample. So statistically, if we are trying to understand something, we are trying to discern what is the population. Population is the collection of everything in that general thing, so general population. For example, if we are speaking about the population of fish in the Black Sea, it means we are speaking about every and each fish in the Black Sea. If we are speaking about the population of Hungary, we are speaking about all the living people that are in Hungary. We are not including Italians or French, only Hungarians. And we want to understand the characteristics of this population. If we are speaking about the population of wine bottles in a given factory, then we are speaking about all the wine bottles in a given factory. This has some issues, because if we want to understand the, let's say, the average of the given population, we must calculate and ask everything. For example, if you want to know what is the average height of a Hungarian male, adult male, we must ask every one in Hungarian population which is his height, to measure it and to calculate the average. And if we want to calculate the average of a population of fish in Black Sea, for example, we must calculate, we must grab each and every fish that lives in Black Sea and calculate its weight, to understand its weight, and to calculate the average. If we want to understand the average liters of wine in each bottle, we must open up each bottle that our factory produces, measure it, and calculate the average. You understand that calculating the averages of the whole population is not feasible. It's time consuming, it requires a lot of money, and so it is distractible. So as a statistician, we want to sample the general population, to sample it, to understand the characteristics of the general population. If we are speaking about, so you understand the differences between general population and sample. Okay, then let's go back to this sheet, this sheet, and let's understand the differences. Let's imagine our population consists of only 15 examples. It's a simple little population, but this will give us an idea of differences between population and the sample. First of all, if we are speaking about population, the terms that describe the population are called statistics and Okay. This is our population. This is our population. It is. You can see it's rising from. It's sorted from the top, from the biggest to the lowest. Is our population. Let's say, and its average is calculated here. Right. Its average is 10 and 87. You can calculate average by putting, I don't know Hungarian word, so this I presume is average on Hungarian. If you put average, the English word average, or the word in your native language, it'll calculate the average. There are some idiosyncrasies with Excel. One of the idiosyncrasies with Excel is that it translates all the functions in each and every language. For example, if we are speaking about like programming languages, for example Python, it does not translate each and every function in other languages because it doesn't matter which language it is, you can read the translation. But with Excel, it automatically translates the function. And one can simply understand what each function entails. So I know this is average. Okay? And this is the average. And this is, let's say we are sampled. And we sample each second item in our population. And we calculated the mean, the average. And as you can see, the average of the population and the average of the sample differ. People tend to think that the averages of samples should be the same as the averages of population. That's not the case. Because samples are random. If you are throwing the dice 2 times, it's like we are taking the sample of general population of all dices now. If you are throwing the dice 2 times, one might think that the average throws should be equal the average of the population of all dices. But it's false, because by random chance you can throw 2 ones or 2 6, which will differ from general population. For example, in this classroom there are a few students. If we say that this classroom is a sample of all the students from this university, no? If we take a sample randomly from a class, it may be that only students that are tall are there, like taller than the national average. And when you take and calculate their average height, it will be much more higher than the average of population. So you must understand that there is a difference between population and the sample. And one more thing, the numbers that describe the population and sample have different names. In population, the numbers that describe the population are called parameters. Why they are called parameters? And by definition, all the parameters are written in Greek letters, like mu, parameter. Populations are ideal constructions. Populations are like functions, which output some values by a function. So in this sense, those parameters can change the function. So that's why in a population, those parameters, those values that describe the population are called parameters. When we are speaking about the sample, the values that we get describing the sample are called statistics. So the statistics is not only the field that describes what is going on, but also are the numbers that describe the sample, and everything that is outputted by the statistical agencies are statistics, because they are calculated based on samples, based on questionnaires. Okay, and these statistics that are outputted by the statistical committees may not be equal to the parameters of general population. Okay? Do you have any questions? Okay. And if we are speaking about statistics, they are written with Latin letters. So X bar is the average, okay, or the mean. Okay, we will speak about this. So as you can see, the calculation of averages for general population and for the sample are the same. We are just summing up all our things that we have in our collection and dividing by the number of things in that collection. But this is little n that says that we are dealing with a sample. This is big N that says we are dealing with general population. Okay? So let me write the first thing like a mean, which means okay, or how it was in Hungarian. There was a word for it. Okay, átlag. Statistically, the average is called mean. Okay, mean. Let's at this time, I like to download real statistics, and work on that real statistics. Let's download some real statistics and see what is going on with that real statistical table, and to calculate some values. Okay, ARStat-AM is Armenian Statistical Committee. I will ask you to go to this website, ARStat-AM. We are going to go to databases, and after that we are going to go to microdata, and we are going to download household integrated living condition summary. And let's, if I'm doing it too fast, microdata and household survey. Okay? Did you manage to go here? Okay? Okay? Let's or just simply type ARStat-AM-EN- question mark NID equals 2005, if you didn't follow. Are you here? Okay, I'll come back. Okay, databases, microdata, household living condition survey. Okay, you are here. Let's download the last one, 2012. Okay. I'll say that Armenian currency is like Hungarian currency. It's quite similar. it's quite similar. So 1,000 Armenian dram is a little bit less than 1,000 Hungarian forints. Thank you, Hungarian forints. So you get an understanding what is going on. Just compare it to Hungarian forints to understand what is going on. So this is a survey database of Armenian households. So it has, you understand it, this is a sample. In this sample, there are around 5,000 cases. Around 5,000 cases. And in this sample, we are interested in this column, total income, which says the total income of a given, which states the total income of a given household. Okay? It's the column P. Column P. I'm not interested in the rest. We are not going to see which column is we are not going to see the correlations between the columns. You are not ready to calculate. We are going to calculate only some things on this only column. Okay? Please take that column P, total income. Copy it. Open up a new sheet. Okay, enable editing. Total income, copy, new sheet, and let's paste this here. Okay, we have it here. This is our total income. You've done it. Okay. Before continuing, let us learn about some statistical charts, because we are not only going to see what's going on by calculating some statistics, for example, the average, the mean, but also we should see what's going on graphically. We should construct charts to understand what is going on with the given data. Okay? Have you copied this column yet? You have. Okay. Are you having problems?
Yes.
Okay, I'll come. Okay, copy, new tab, and
No, it's because, yes, you have to, I know, no, copy, no. You have to, yeah, same. Yes, because there is no but I can put also, yeah, I can
So the guys have copied, only the girls are having problems, no? And I'm having the same problem with girls. The Excel stopped
okay.
working for
Just
Just crash?
yeah.
Ah, for example, and yours is crash too? Yes?
Maybe we can change the temperature.
Yes,
For
you
example.
can run. But I don't know that. And the other, İzlerden var mı?
Okay, let us continue. We are going to explore, as I said, we are not only exploring the statistics using the numbers, like averages, to understand what is going on, but we should examine the data using graphical instruments as well. And let's use one of the most important graphical instruments in statistics on this data. So this is the total income of each household in a month, averaged. Okay, but this is a sample, as you understand. What we are going to do is to take all this data, Control Shift down. Okay, put your finger like put your mouse on A2, then Control Shift down, and you select all the data. Okay? Down. Control Shift down. Control Shift down. Okay? You select all the data. Then let's construct. Then. Okay. Then let's go to charts and select a histogram. Okay? You will have a chart like this. Okay. Okay, I'll show you again. Charts, charts here. And we are going to histograms. Okay? Histograms are the first statistical charting tool you must learn. Okay? What is a histogram? Histogram is used with samples to understand what shape our general population might have. Because this is a sample, you understand that this is a sample, there might be a function like this that describes the general population. Like in this case, the sample that is the function that describes the general population might be like this. It goes up and goes slowly down. Okay? In this case, what did histogram do? Histogram just counted. Histogram divided our data to bins. What is a bin? Bin is a basket. Divided our data into basket and calculated how many instances are in each basket. For example, in this case, from 0 to 58,000 grams or florins, have 200 or so families from all the cases. Okay, but as you can see, we have some rare cases here. Somebody said that his household has the monthly income of his household is 6 million. So it's an outlier. It's a big number, somebody said. And to understand better what is going on, let's correct all of this. Okay? Let's correct all of this. How we are going to correct all of this? Just put your mouse 2 times click here, okay, the panel will open up. Tengeli formazasa. Okay. And we'll say that our maximum, our maximum is not 6 million. Just click this. Our maximum is not 6 million, but let's say 1 million. 1 with 6 zeros. 1 is 6. Okay. 6 million. And let's say that our bins are not 58,000 because it shows this number it just shows this number on a parameter, so it's divided on equal 30 parts and calculated that this number should be chosen, but I don't like this number. Let's choose other number, let's say 25,000. Okay, and we'll have our graph, and let's say that okay.
So I don't have the interval.
Go here. Okay. Interval.
Yeah.
Yeah.
Yeah.
Let me consider. Okay, everybody did it. You girls are behind, I feel like. Okay. Insert, this is English, this is good. Histogram. Then, overflowing. 1 is 6, so 1 with 6 zeros. Not 6 zeros. And in with 25,000. Okay. The same with you. Control Shift down to select everything. Insert. Insert. Histogram. Chart. Histogram. This overflow bin 1 is overflow bin 1 is 6 and this 25,000. Okay. So what we have? What we have? This is like all 5,000 cases we have, all 5,000 samples we have in a graph, in a calculation of a graph. So as we can see, in Armenian population, in these 5,000 cases we have, from 0 to 25,000 florins, let's say florins because you know something, 25 from 5,000 have so little money. Okay? Main part, like you see this is a main part, is from 75,000 to 100,000 florins. But we have people like around 75 that have more money in a month than 1 million florins. Okay? So we understand right now what is a histogram. Histogram makes us understand what is going with this thing. Okay? And as we can see, this data is skewed. So the main part of the people that the main part of people is here. They have like they earn less than let's say 400,000 florins. Okay. But there are quite a few people that earn more, but it's very few percentage. Okay. I don't know, this is Armenia, but are the wages in Hungary the same or a little bit higher?
Not too much higher.
Not too much higher.
Nothing.
Okay. Okay. And we graphically see what is going on. Let's calculate right now the statistics. And the first statistics we are going to calculate is the average. Let's cut this graphic and go up and paste it somewhere here. So we are in the top. Okay? I'll take my coat off. Or let's open a window. It's quite hot here if you don't want me opening the window. Let us continue. Okay, let's calculate the average. So we will start by this will be our mean. Okay, the average. And our mean, like in statistics, the average is called mean. Okay. And our average will be. I don't know where is the sign for equals. Okay, I found it. Outlier. Where is outlier? Okay, outlier. And we are taking the first number. Control Shift down. Control Shift down and enter. And it has calculated the average value. Have you calculated the average value? Okay, all have calculated the average value. I'll continue. If somebody is left behind, or feels that he doesn't understand, please ask. I may rush a bit, but if you feel that I'm rushing, please stop me. Okay? And let's say that we want say that it is a number. This will be that it's a number, and we don't need the sense. So we'll say back. Okay, this will be our number. Format. As you can see, the mean or the average, which was the summation of all values divided by n, is around 300,000 florins, which is somewhere here. It's here. It's here. Okay. Have you thought before calculation that it will be here, not let's say here or here?
I suppose, because
You supposed it should have been here, no?
Yes.
Or here, not here.
yes.
So the question is, why is this so high and what it can do? I'll say that in statistics there isn't one calculation of the average value. There are several tools with which we can calculate the average value. We have learned only about the average, the simple mean. Okay, but there the two more that we should know about as statisticians are median and mode. And all of these are central tendencies. Central Okay. Before, let's ask the question, what are central tendencies? Central tendencies are points that show us where is the center of our distribution. Because if we have some random distribution, we'll expect that the center will be somewhere here. No? But in this case, the calculation of the mean says that the center is here. But maybe the center is here, the peak, or somewhere here. Why is the center is here? To answer it, we must look at the extreme values that are here. The extreme values that are here. Because let's go back to that. Okay. In this sheet, mean answer. We are calculating the mean. Now, 60, 68, the test scores. What are the test scores? 61 student has 60, the other one 68. We are calculating the test score, and the answer is that the mean or the average test score is 67 and is around 67. But if we change some of the test scores, let's say we have 31 here. Let's change this 31 to be 100. Let's see. We jumped to 71. So if I change this, for example, to be 1000, we understand that test score 1000 doesn't exist, but let's say. See what will happen with the average test score. It will jump high. I'm not changing anything, only one value. And the average jumps up. So, yes. Do you have a question?
No.
And the average jumps up. The same is here. We have a lot of big values here. A lot of big values. And if we have big values in a system, the average will jump up. For example, if I add 2 zeros here, let's say 1, 2, 3, let's add more. See how the average jumped. With one outlier that has 10 million or 100 million florins average income. It jumped to this number. Okay, so Control Z. Control. Okay. It's jumped way up. So the mean. Let's understand what are those values. Those values are called outliers. Outliers. Outliers are the values that are deviated from the central part a lot. So if we have the central part and we have a deviation from the central part a lot, a point that deviates from the center a lot, then it's an outlier. But we must treat with, the outliers with care, okay? Because if we have an outlier in our system, it can mean quite a few things. But we can have outliers, okay? And if we have extremal outliers, our average will jump up or down, okay? Because averages are not a robust statistic. What does mean robust statistic? Robust statistic is a statistic that it doesn't change if one point in our data changes. And just simple average mean is not a robust statistics, because it can change a lot if one value in our system changes. Okay? Okay. And this value, around 30,000 florins, let's say it was, where it was, here, 30,000 florins. This doesn't mean that 50% of the population, or of the sample, earn more than this, or 50% of population earn less than this. Because we have a lot of outliers, okay? In reality, if you see that the average price of a house, or the average income is, let's say, 300,000 florins. It doesn't mean that 50%, it divides the population equally into 50%. More than 70–60% of population may earn less than this number. Okay? All understood me?
Yeah.
You girls understood me?
Yeah.
Okay. And what is your name? Trez. What is your name? Gary. Dani. Did you understand me?
Yes, of course.
Okay. And that's why we are going to learn the next about next central tendency, about the next average value, which is called the median. Okay. Median divides our values equally. So median is a point that divides our distribution equally into 50–50%. So from that point, 50% of all the values are from the right, and 50% of all the values are from the left. Okay? So if we have, let's say this is the house prices in dollars. Okay, we have house prices, let's say in Budapest, but in dollars. Okay, we want to find the median house price. Or these are the salaries at an accounting firm, and we want to find the median. Because if we are dealing with prices or with salaries, it's better not to ask what is the average, but to ask what is the median. Because median will give us more intuition where is the half point, which divides the population into two equal parts. Okay? How is median calculated? First of all, let's see. You can do it the same here, but I'll show you just the red ones, okay? How is the median calculated? Let's say this is our sample of salaries in an accountant firm, okay? Or you can imagine those are house prices in Florence, in let's say suburbs of Hungary, or in Hungary, because I imagine this will be around the same in dollars like house prices in Hungary. No? Okay. What we are doing, we are sorting all of our data in descending order, in ascending order. Okay. We are going to sort all of our data in ascending order. I can show you how we are going to, how we are doing it. We can just delete, we can just copy of all our data, copy, then paste, then then say data at A to Z. Sort by A to Z. And it will sort in ascending order. Okay? And after that, if we divide, if we look for the middle point, in this case we have 21. In this case we have 21 rows in our sample. So 10 rows from the top and 10 rows from the bottom, if we go, will give us the value that is in the middle. So median means something that is in the middle. And this value will tell us what is the median value. So if you are asking about the house prices or about the salary, don't look for the average price, okay, or the average salary, because it might be skewed by the outliers. Because we can have, you understand that in this town, the average house price is around 70,000. No, around should be around 70,000 euros or something like that. No, around 70,000. But you understand that there are quite a few houses that are 1 million, 2 million euros. And those, or 10 million euros, somebody built a big house, something like that. And these houses may affect the average value. So that's why, if we are dealing with money, one should not ask for the average, for Outlier. One should ask for the median value. Okay? And median is a robust statistic. It does not matter if I change something in our data. For example, here I'll calculate mean, mean, which is average, outlier, and median. Okay, let's calculate both. I'll write this equals to outlier, outlier. Okay, all of these values, and this will be equals median all of these values. Okay. And you see the median is 110, around 110,000, which divides our sample in two equal parts. But the mean is 160,000. And if I increase, if in our sample, let's say this is the maximum in our sample, if in our sample there is a bigger number, let's say 79, 7,900,000, around 10 million. Let's say the mean, the average, jumped to 500,000, 500,000, but the median stayed the same. Okay? Let's go back to our sample of household income, total income of households, and calculate the median. By the way, I didn't say that if we, this is even, so it chooses the middle number. But if we have, this is odd number of cases, so it chose the middle one. But if we have even number of cases, it will choose the average, simple average of these two cases. So it will sum up those two cases, divide by 2, and that will be the median. Okay? Okay. Let's go back to our sample of around 5,000 households and calculate the median. Which will be equals shift equals median. This control shift down, enter. And let's have it be like this, okay? And we do not need the cents, okay? And the number is 230,000, so it will be around here. So I want to color those two columns. So this is our, one moment please, our mean. And so the green is our average or mean, outlier, and the red is our median. What median does? So the weight of all these bars from the left is equal to the weight of all these bars to the right. So it divides those parts equally. Okay? So you right now understand what is the mean, the average, how is it calculated, and what is median. Do you have any questions? Daniel? Okay, understand everything. Girls? Do you understand everything? The Italian guy, what's your name?
Jonathan.
Jonathan?
Jonathan.
Jonathan, okay, that's an American name. Jonathan. Jonathan, okay. So everything is understood. Capish? Okay. So the next thing I'm going to talk about is this. Because some of you may think that the average should be here. Because in all of our distribution, most people have salary from 100,000 to 125,000 florins. Okay? And you might think that the salary must be here. No?
It's moda, right?
Okay, this is the mode. Yes. What does this word mean? Moda. Mode. The word moda has the same root than the fashion. Mod. Modni. Okay? You have what's like the fashionable fashion word in Hungarian?
For what?
Huh?
For what? Sorry?
Fashionable. Moda.
Divotisch.
Divotisch. And in Italian?
Moda.
Moda, okay. So this is a Latin word, moda, which means fashion. And it has the old sense, like something that is widespread, something that all has, okay? Okay. So mode means the thing that a lot of people have, okay? And in a statistical sense, this is the peak of our distribution, okay? The peak of our distribution. So you can see that the peak is here in this distribution. This should be the mode, okay? I do not advise to calculate the mode for samples because it will lead to some mistakes, to be frank. Because humans like round numbers, and if you ask a human what is your salary, he will not say 151,076 florins. He will say 150,000, because humans like round numbers. That is why a lot of people will say a round number, and your peak will be in that round number if you are taking samples. That's why I advise against calculating the mode when you have a sample. A mode should be calculated if we have a function, because a function will truly show where is the peak of our function. Then it will be calculated by derivatives. Okay, you know what are derivatives? Okay. Okay, mode. And this will be our mode. Let's cover it. I don't know. Okay. Okay. So let's say you finished you finished the university and want to go in a banking business. And you know that the average salary in a banking business, let's not say banking business, because banking business has high wages. Let's say another business, I don't know, factory. And you want to go to work in a factory. And they tell you that the average wage in a factory is around 300,000 euros. You would say, oh, that's great. I will be factory. The average income will be around 300,000 euros. That will be great. But the reality is that the average is dictated by those outlier numbers. And in reality, 50% of people will have around 230,000 florins more and 230,000 florins less. So you will expect in reality that you will have less than 230,000 florins, not in the middle. Okay? But we are going further, because if you are first time in a job position and you want to work, the reality is that you will be in like all others starting in the same position. In reality is that you will be closer to the mode. Okay? Let's calculate the mode. Once again, I don't advise using mode on samples, but in this case we are going to do that. There is no mode in, I don't know how it will be in Hungarian. Let's see. Let's see. Median and where is mode? Okay. Mode. Modus. Okay, this will be our function. Okay, and this will be our mode. Okay? Understood?
Yes.
Okay. Okay. So we'll learn about mean, about media, about the mode. Reconstructing the histograms. We understood what are the histograms. Okay. It divides our sample data in packets, in bins, and just counts how many are in each bin, in each packet. Okay? Okay. And we learn what is mean, what is media, what is mode, how are they calculated. Okay. And we learned about the population and the sample. Let's right now open normal distribution. This page. I'm going to use the Wikipedia. They are not. Let's not use the Wikipedia. Let's do here. Okay. This is the normal distribution. In the following lectures, your main lecturer will explain you what is the normal distribution, and you will do a lot of things with normal distribution. But I have opened the normal distribution for you to visually see where are our three central tendencies. Let's open this. Okay. Okay. First question. Where is the mean of our distribution?
Yeah.
It's here. Why is it here? Because it's symmetric. If you like sum those things and those things which have the equal likelihood, if you sum equal probability, if you sum those two things and divide by 2, you'll be here. The same is true with all other points. If you sum the things that are equal distance from the meter, sum those two things and those things which have equal probability and divide them by 2, you'll be in the middle. So our mean is in the middle. Okay? Where is our median? Our median is on the same point because 50% of our points are here and 50% of our points are here. It is symmetric. Where is our mode? In the same place. It is here on the top. Thus, if we have a symmetric distribution which has one top one top point, then these 3 points, mean, median, and mode, are the same. And in the case of the symmetric distributions, you will use mean to describe where is our center. Okay? When we have a skewed distribution, like we have in this case, which is not symmetric, then those 3 points are different in different places. Okay? We'll speak about this later. But let's us go back to it. Okay, we are going. But I forgot to tell you that median, like, okay, no matter. Let's go to skew. Let's go to skewness. Okay. We understood what are central tendencies, no? Okay. Before going and learning about the skewness, let's us learn about the mathematical moments. About moments. I need moments. And I need one moment, please. I want to find. Moment. So okay, this is a good picture. This will do. Okay. Agree. Okay. I want to speak about the moments. Okay. Moments of a function. And if you are talking about the functions, we are talking about general population, because general populations are outputting the probabilities, okay? And we are sampling general population. Ideally, mathematically, the general population is just a function which outputs the probabilities, okay? Girls, you listening to me, no? Okay. General population, okay. If we are speaking about the moments are parameters that describe the condition of our population. We have learned about the first moment. The first moment was the middle of our population. So if the first moment changes, the graph of our function stays of our functional population stays the same, but it just changes its position. Okay? This is the average. So average mean is not only the central tendency, one of the central tendencies. It is the first moment of the population. We are not going to speak about the second moment yet, which says that it says how much are spread our data is from the central point. So bigger, smaller, so more spread, little spread, okay? We are going to speak about the third moment. The third moment is skewness, which shows how much our population is skewed, okay? And right now, we are going to go back to this and speak about the third moment, skewness. Because skewness shows if the skewness parameter, skewness is 0, then our distribution is not skewed. It's symmetric, right? In that case, normal distribution. If it has a positive skewness, it is skewed to right, like in the case of the wages of population we just learned. If it's negative, then it's skewed to left. Okay? Let us calculate these things. Okay? Skewness. Skew. Okay. This is a sample data 2. Okay. In this case, the average are plugged, the median and the mode are the same. Okay, and you can see it graphically. It's symmetric. In this case, the mean is the biggest because we have some outliers that pull the mean to them, big numbers. Then comes the median, and the mode is the peak around. And the mode is the peak 7. And in the other case, the reverse is true. So as you can see, if we have a skewed distribution, the mode is always in the middle between the mean and the mode. The median is always in the middle between the mode and mean. Okay? Okay. Okay.